Thank you, Mr. Chairman. And first of all, I would extend my sincere thanks to Professor Takara Sensei. Okay. And distinguished the professors who are leading this very important UNESCO chair activity in Kyoto University. I would introduce our center, the ICHARM, and also its activity in collaboration with many countries at this moment in Asia. ICHARM is the International Center for Water Hazard and Risk Management. This is the Category 2 Center of the UNESCO, hosted by Public Works Research Institute of Japan. Our motto is challenge to localism by delivering the best available scientific and technological knowledge to the local practice by the research and education and the networking. So these three are the key pillars of the ICHARM. With regard to the research, we develop various integrated flood and drought analysis system, and this rainfall runoff inundation RRI is mostly widely used the system developed by the Dr. Sayama when he was in ICHARM. And by combining the ensemble, the rainfall prediction, we can develop the ensemble flood prediction, and by coupling with some socioeconomic models, we can provide the impact of the flood and drought on the socioeconomic benefit. So the risk assessment tool, integrated risk assessment tool, are now available, and in addition to the RRI, we added the water and energy budget component, and then the long-term simulation river discharge and inundation, considering the water and energy budget for long term. So that's why we can identify the initial condition well. So this is the 11 ensemble prediction of the flood. Every 24 hours, we are now doing a 48-hour ensemble prediction in Sri Lanka, and this is the case of the flood event May last year. So in Japan, we had a series of the flood and the sediment, the disaster recently. In this case, last year, within 12 hours, more than 550 millimeter rainfall happened in northern Kyushu, and a huge number of the landslide happened. And the landslide occurs the mud flow in each the valley, and the sediment, the diameter around the 2 millimeter are flown down due to the flood, and it's the sediment in a more mild slope river, and the very narrow river is filled by the sediment, and in the valley, the flood and the mud and the flood happened, and very serious disaster damage occurred. So this type of the serious flood and sediment disaster happen more often in Japan. Steep the valley, we simulate the mud flow and also the water and the sediment both, and the more mild the area, the water and the sediment fills the river, and then water they land freely in the valley. So this kind of the simulation system has been developed. So and with regard to the training, we have a master course funded by Japan International Cooperation Agency (JICA), and also the PhD course. The master degree and the doctor's degree are provided in collaboration with National Graduate Institute for Policy Studies. So in this framework, our ICHARM is much more natural science aspect, but the student study the policy, learn the policy study, and in some cases this student they come from the government of Malawi. He belongs to the planning division of the disaster risk management. He is more social science person originally, and he learned our numerical modeling system and the climate change impact assessment system, and then he developed a master thesis how to mitigate the climate change impact in his country. Due to the very unique topography, the inundation depths will increase dramatically. So that's why the evacuation system and also the alarming system is very critically important. He developed such kind of the master thesis, and in September 2 years ago, and he returned to the Malawi, and very fortunately UNDP and World Bank they hosted a workshop, and he made a presentation, his master thesis, and his thesis was adopted as a UNDP project due to with the US $60 million the project. He is now leading the project in his country. So this kind of the self-transdisciplinary study is now ongoing in our center. So with regard to the information networking, the UNESCO, IHP, and the WMO, in collaboration with UNISDR, UNU, and the International Association for Hydrological Science and International Association of Hydraulic Research, IHR, they are now leading the International Flood Initiative, IFI. And ICHARM is working as the IFI Secretariat. And this was established in 2005, and under the new framework of the SDG and the Sendai framework for disaster risk reduction and Paris Agreement. Through the series of the meetings at the UNESCO IHP, United Nations headquarters, or regional meeting, and the World Water Forum, we established a new framework that is a platform on water resilience and disaster. In addition to hazard data, damage and socioeconomic data are archived for implementing the integrated risk assessment. but risk itself is changing due to the societal change and the climate change. This risk change should be identified and monitored and predicted. And then usable information could be passed to the policy makers and the community of practice. So data archiving and model development and then creation of the societal benefit. This framework could be done interdisciplinary collaborative framework and transdisciplinary collaboration between the science and technology community and society. And leader of this program should be grown up. So capacity building is critically important. We propose this framework, and we are now doing this platform activity in several countries. Our strategy in each country have various agencies and departments and university also, and our IFI partners have a close collaborative framework with each department or agency or university or academia, and in collaboration among each country department and also the IFI partner, we can develop the integrated collaborative framework. We also invite space agencies and group on Earth observation, and then we establish the platform in each country. And cross-cutting collaboration, for example, in a region, we can promote such kind of collaboration. This is our strategy. So in this framework, the data integration, integrated risk assessment is very important. For that purpose, we provide our data facility, data integration analysis system. This has been developed by our government under the framework of the National Key Science and Technology. This has a very huge data storage and also the computational resources and also the IT expert. On the platform, various the discipline can collaborate together for promoting integrated interdisciplinary the science and technology. So our government identified this DIAS as one of our Japan's contribution to the SDG, and the volume, huge volume data archiving and also the huge variety data archiving and effective use are the key component of this DIAS. So this system is available in this platform. So hazard damage socioeconomic data integration and early warning. This system, one of this system's the capability is real-time data assessing. So early warning can be done by using this system very easily. And then the climate change impact assessment. All of the IPCC assessment report 5 data is available through this system. So dynamical and statistical downscaling can be supported. So in the United Nations framework, the former the Secretary General and World Bank the president established this high-level panel on water which consists of the 11 head of state and two special advisors to this panel. And the high-level panel on water established the final document March in this year, that is making every drop count. So one of the 6 key target is resilient economies and society and disaster risk reduction. So in this document, the platform on water and resilience disaster among all stakeholders should be formulated in countries to facilitate dialogue and scale up the community-based practices. So they recommended our activity in this high-level document. So and we are now working with 4 countries in Asia, Pakistan, Myanmar, Philippines, and Sri Lanka. They established the platform in each country, and we had a various meeting, and they identified initial targeted river basin. And this is one of the example in Philippines. So Science and Technology, Department of Science and Technology, Hydromet, River Bureau, Disaster Department, Economy, Statistics, Geology, and 3 University of Philippines, the Dilban, Mindanao, and Los Baños are joining. And they established this platform. First target is the data archiving. I propose the damage data and hazard data and socioeconomic data list. And the participant raise hand. My department provide this data, and my department this data. So all of this data is now being archived by DIAS. So they want to share the data among the different departments and agencies, and we are supporting that activity. So this is a case of the Sri Lanka, the Irrigation Department, the Disaster Department, Meteorology, Geological Survey, Land Use, and this is the Ministry of the Megapolis and Western Development. So these departments joined and established a platform. Very, very unfortunately, the May last year, they suffered the very serious, the heavy rainfall, disaster, flood and landslide happened. After that disaster, we established a collaborative framework with them. So more than 5 millimeter rainfall happened, and the south western part of the Sri Lanka, the very serious damage happened. Within 1 week, by using a DIAS, the Institute rain gauge data monitoring every hour, and the satellite, the rainfall bias collection output is available, and Himawari geostationary satellite data is available, and also our ALOS, the sensor, the inundation area mapping by using the ALOS sensor, and inundation prediction system, as I mentioned in my previous slide, is now working. So this kind of the system is now being provided to the government of Sri Lanka. So, and this high-level document mentioned the Global Research Network and Global Disaster Database integrated science tools for assessing risk, and a global platform integrating science and policy, including higher education. So according to this message, we are now working with our collaborative partner, GRIPS, the National Graduate Institute for Policy Study. They have the Science and Technology and Innovation Policy Program, and also the Disaster Management Program, and our ICHARM covers more science and technological natural science component. So targeting the PhD course, higher education, we are now collaborating together and develop a new course which covers the science and technology and also the policy study for disaster risk reduction. So very fortunately, JICA provided 2 positions of the PhD student, and the 2 students will join in October this year. So the new course will start, and 1 professor assigned for managing this new course, and he will establish a new laboratory to manage this new course. So in this way, we are now doing research and training and networking for realizing the challenge to localism. Thank you very much for your attention.